Good morning, ladies and gentlemen. It's Dr. Jones here. Now today we're going to do something a little differently. Normally I have a segment for my middle school students and a segment for my high school students. But today I'm actually going to be talking to both groups, and here's why. When you're looking at standards and really when you're looking at science, especially starting at the very low or the very young age group, we just build on what you already know. We increase the level of information and the depth of knowledge. So what I'm going to be doing today is actually showing you how some of the same standards and same information you learn in middle school comes back around and you learn it again in high school. And to do that, we're going to start with this topic, from atoms to ecosystems. Okay? Now, first of all, let's talk about our standards, because we always want to go back to the standards. If you notice, both of these standards, one for middle school, 6-8, one for high school, 9-12, both have the PS1A1. So that lets you know that they're linked. But here's the difference. In this standard, we're talking about molecules and really atoms and the model of an atom. Meaning, okay, what does an atom look like? In this part of the standard, we're taking it one step further and saying, okay, well, how are atoms organized? So in this segment, we're going to be talking about atoms and how that will then lead into our discussion about life on this planet. Okay? So, first off, what is an atom? Now, for those of you who have those Twitter fingers that are just like Google fingers, you probably get, oh yeah, I know what atom is. Atom, smallest unit of matter. Okay, cool, marvelous. But I have a question for you. What's matter? Now, for some of you, you know this off the top of your head, but for others, you're like, no problem, Twitter fingers. Oh, yeah, got it. Matter. Anything that has mass or takes up space. That's also called volume. So then my question to you is, okay, good, mass, wonderful, you got that. Matter, good, wonderful, you got that. But what does that mean? I mean, how do you measure mass? What do you measure mass in? There's a unit for everything. For example, if I say, oh, give me a time, you're going to give it to me in hours, minutes, seconds. If I say, how fast is something going? You're going to say either kilometers per hour, miles per hour. When you start talking about mass, you're really talking about grams. And when you're talking about volume, you're talking about liters. Case in point, if you go down to the store and you want to get something to drink, you're going to get yourself what? A 2 liter. Or a 1 liter if you're at the convenience store. Or you're going to get yourself what? I don't know, 24 ounce drink, 34 ounce drink, 32 ounce drink. Yeah, I don't think that's 24. Yeah, there is a 24. We won't even want to talk about 40s. That's for when you get older. All right, so moving right along. So let's talk about matter versus not the matter. Now, before we go on with this discussion, I'll tell you right now. Some people know who this kid is. Others are like, what you doing with that ugly baby on screen? All right, I'm about to date myself, which basically means I'm about to tell you how old I am. If you don't know who this is, do me a favor, call your mom and them. Mom and them is the way we say in New Orleans, your mom or your dad. Say, hey, mom, that man on the television said he needs you to come sit here and talk to me. Here's why. He said, tell me who this is. So, basically, I'll give you the short version of it. There was a show called Dinosaurs. In the show, there was a baby. The baby had a dad that he never called dad. He called his dad not the mama. Not the matter. Corny. Dad joke. I'm a dad, so I'm working in the realm of what I can do. All right. So, let's talk about matter versus not the matter. All right, so back in the day, we used to play a game called 20 Questions, which you had 20 questions to ask to figure out this unknown entity, whatever it was. And entity means just anything, right? So there was one question that you would say, okay. Is it an animal, a vegetable, or a mineral? Well, here's why people ask animal, vegetable, or mineral. If you think about your animals, do they have mass? Yeah. I got a dog at home. She's a little dog. She weighs like 25 pounds. If I convert that into kilograms, I don't know, that's like 12.5, something crazy like that. Anyway, she has mass. Does she take up space? You better doggone right she take up space. She try to take up space in my bed. I'm like, we good, but we ain't that good. I'll let you get the sofa. I'll let you get a little room on the side, but you're not getting in my bed. Ain't working. All right? Vegetables, fruits and vegetables. We know these things have mass. Go to the grocery store. There's a scale there. You want to know how many bananas you're going to be? You buy bananas by the pound. You don't buy them by the banana. And if you're in a place that sells bananas by the banana, please leave, because they're going to gut you for your prices. They're going to take all your money. You don't mess with them. And then minerals, rocks. Everybody knows rocks. They take up space. And everybody knows rocks have mass. But let's get to the things that we deal with every day that don't fall in this realm. For example, light. How much space does light actually take up? Let's be real. There's light in this room right now. Can I put it in a box? No. Sound. Sound waves are traveling back and forth. Tell me something about how much sound I'm putting out right now. 50 pounds? 60 pounds? And then heat and energy. If you think about it, none of these things have mass and volume. Therefore, they're not matter. All right, so we're going to play a little game. Your turn. Matter, not matter. Let's start with the first one. Water. I give you a little time. Matter, not matter. All right, so check it out. Does water take up space? Yeah. We just said you can buy a gallon of water. Gallon is a number that coincides with volume. Does it have mass? Yeah, water's heavy. Try to pick up like 5 gallons of water. You're going to have to put your back into it. So water, that's matter. Air. Oh, is air matter? Well, let me ask you a question. If you put air in your tire, what are you measuring it in? Pounds. Is pounds a form of weight? And is weight related to matter as far as mass? Yes, it is. And when you put that air in the tire, does it take up space? Yes, it does. So air is what? Matter. Fire. Okay, I'm gonna make this one easy. So, go in the grocery store. Dad said, hey, look, I'm gonna do a cookout. All right, cookout, great, wonderful. Go to the grocery store, you say, hey, look, I need to get like 5 pounds of chicken. Cool, 5 pounds of chicken. I need to get 2 bags of charcoal. Okay, 2 bags of charcoal. Does your dad then go and say to the butcher, yeah, give me like 10 pounds of fire? No, because fire has no mass. So if fire has no mass, fire is not matter. Earth. Come on now. Rocks? Soil? Does that take up space? Yes. Does that have weight? Yes. So is that matter? Yes. So here's the thing I want to bring to a whole. If you ever saw the movie Avatar, remember there's a TV show with a little kid, and then there's a show, or the movie. In the live action movie, if you recall, firebenders had to take fire and then bend it. Here's why. If you look at water, it's matter. He can control water. If you look at air, it's matter. He can control matter. You look at earth, it's matter. How do you make fire out of thin air? Right. That's what we call cartoon/movie magic. All right. Let's bring this all up. So, just like you have states of being, states of existing, you have states of matter. Now, states of matter are not just like, Missouri, Arkansas, Kansas, and Oklahoma. No. States of matter is basically, how can I find matter? What does matter look like when I find it? So, There's 4 states of matter. I know. Folks are like, 4 states of matter? I thought there was only 3. Plasma. Yeah, so like I said, we start you off here at the low level. We tell you there's 3. We know there's 4, because here's the thing. When you start getting to like neon lights, when you start getting to like plasma screen TVs, when you get to like the sun, now you get to this other state of matter, plasma, that is going to take me longer to explain it than for you to understand it. But think about it like this. It's not quite a gas, but it's not quite a liquid. Okay? So, notice what you have here. You have solids, you have liquids, you have gas, you have plasma. What's the difference? The amount of energy. Energy is not matter, but energy matters. Right. There's some things that ain't matter that matter, and there's other things that are matter that don't matter. Let me make it plain for you. Right now you're listening to me, but there's a lot of people that's listening to me, and they got the little chick on Snapchat or Twitter, and you're just like, yeah. I'm gonna tell you right now, that little girl, especially if she ain't your girlfriend, she don't really matter right now. I know I didn't say that out loud, but she doesn't. This matters. Now, after you have, some cash on you and stuff like that, then she'll matter. But right now, let her ride. She'll be okay. All right, now, let's talk about the atom. Because again, remember, that's where this whole conversation started. It started with what? Atoms, right. So, when we look at atoms, understand that atoms have a certain order to them. Here's what I mean. All atoms have a proton, or protons. All atoms have neutrons. All atoms have electrons. The proton is the positive part, the electron is the negative part, and the neutron is the neutral part. Now, a lot of people get neutron confused with negative. They're thinking neutron negative, neutron negative. No. Think neutron neutral. Or think neutron, Jimmy Neutron. Yeah, I didn't put the picture up because, I could only get away with one Nickelodeon character. I start putting 2 on, then like people gonna be looking for me like, Dr. Jones, you put my kid. Yeah, I don't want that. So anyway, here's what I want to say about Jimmy. Jimmy Neutron was a character that wasn't really good. He wasn't really bad. He was a real smart kid, but he wasn't a mean kid. He was like even keel. Neutral. Neutron. All right. So, we got our atom here. Now, one thing that I wanted to bring your attention to is this side. Nucleus. Here's why. You've heard nucleus before. In terms of this, a cell. Now, here's the deal. The nucleus of a cell is where all the business happens. This basically tells the cell what it is, why it's there. The nucleus of an atom does the same thing. The nucleus is what really identifies an atom as who it is and what it can do. Got it? So anytime you see a nucleus, don't think of it as control center as much as identifier, because inside a cell, the nucleus houses your DNA. Your DNA says who you are, what you do. Inside the nucleus of an atom, you have your protons and your neutrons. The protons tell an atom who it is and what it can do. Okay? So, again, if you look at an atom, your mass is here, protons plus neutrons. It takes up space with the protons, neutrons, and electrons. That's why all matter is composed of atoms, and why an atom is the smallest unit of matter. Now, ladies and gentlemen, I want to bring your attention back to our standards, okay? Because again, remember, we're talking about how middle school and high school come together, and how although we're talking about the same topic, we go from middle school, which is like level 1, to high school, which is like your level 15. All right? So we have already talked about an atom, what it is, what it's composed of. Now we're going to get to the arrangement side of this, the periodic table. And here's why. Order out of chaos. Ladies, if your closet looks like this, there's a whole lot of chaos. But here's the thing. If you really, really, really want to up your game, you want to get it like this, to have order. Well, let's talk about atoms, because again, we just said atoms are the smallest unit of matter, and we already identified that matter's everywhere. So how are we going to take all this matter and group it up? Well, there was a guy, Dmitri Mendeleev. He's Russian. So Dmitri, he's a scientist, and so he's sitting around, you know, and I know that because Kevin, who's Dimitri's friend, Kevin told me. So not my words, these are Kevin's words. Kevin said, yeah, me and Dimitri, yeah, we were hanging out one night, you know, and we went home to his house. And so he gets in the house, and his wife says, Dimitri, you got all these atoms all over the place. You got to organize and make them look better. He's like, because, you know, you see you got a SIG, so you know, all right, baby, all right, I'm going to do a little something with it. So Kevin's sitting over there on the side. Dimitri's like, let's figure out what we're going to do with these atoms. So Kevin's like, all right, what are we going to do? So Dimitri says, okay, well, if I look at carbon, for example, we got a carbon 12, we got a carbon 13, and we got a carbon 14. Kevin said, so what you going with? Dimitri says, so Kevin, look at this. You have 6 protons here. You have 6 protons here. And you have 6 protons here. Kevin like, okay, good. 6 protons. What you trying to say? He's like, notice, Kevin, 6 neutrons, 7 neutrons, 8 neutrons. All of this is carbon. What didn't change? Kevin was like, the protons. He said, exactly. So protons have something to do with an element being an element. But Kevin said, okay, well, how about the electrons? He said, okay, let me look at this again. So then he said, oh, look at this. Isotopes, right? He said, look, again, nitrogen, 7 protons, 7 protons, 7 protons. All right? 7, 8, 9. All nitrogen. He said, okay, you showed me 2 examples of the protons and the neutrons. I got it. Protons have something to do with it. But what about the electrons? He said, hold on. So then he started mixing up solutions. Now here's the thing. Metals, depending on how many electrons, will act differently. Here's what I mean. So you got something called vanadium. Vanadium, if you have a +5, which means it lost 5 electrons, it has like a goldish color. If it only loses 4, it's a light blue. If it loses 3, it's green. If it loses 2, it's purple, but it still has the same number of protons. Same thing for chromium. Same thing for magnesium. Same thing for iron. He was like, Kevin, do you see what I see? Kevin's like, yeah, man. Electrons deal with the color. He's like, no. Protons stay the same, but the electrons can change. He was like, I got it. So, if you look at the periodic table, here's what Dmitri was able to show. If you go 1 proton, 2 protons, 3, 4, 5, 6, 7, you can line up all of your elements based on the number of protons. And for those of you who are in chemistry right now, that is called the atomic number. So what is the atomic number? The number of protons. Now, I'm going to hit you with this one. I just told you, all matter has to have neutrons and electrons and protons. And when we look at matter, we're talking about our atom. We said that the electrons are on the outside, But in the middle, the nucleus is the proton and the neutron. So when we talk about the mass, we're talking about what? Protons plus neutrons. So Dmitri created not all of this, but a good bit of this. So now we have this periodic table. Dmitri is like, yes, I've done it. But you know how everybody goes. They look at your work and they're like, you know what? I can do a better job than that. So here's what happens. Dmitri created this. Somebody comes after Dmitri and says, wait a minute, I got a better way of doing this. Let's look at the periodic table and break it up based on metals, metalloids, and non-metals. Think of it like this. Stuff that's solid, that's a metal. Stuff that acts like a metal. Stuff that doesn't act like a metal and could be a solid, a liquid, or a gas. Now, I have to say one thing. Everybody knows about quicksilver. That's mercury. It's a liquid and it's a metal. But for everybody else, you know. So now, oh yeah, I got this periodic table and now I can really just look at it and I can tell the difference between my metals, my metalloids, my non-metals. Somebody said, okay, yeah, I see. You got a nice car, you put some rims on it. That's great. I'm about to really trick this out. I'm going to break it up into its families. Whoa, wait, families. Here's what we mean. I have two sisters. Me and my youngest sister, we act alike. We don't look alike, but we act alike. And we go from 0 to 100 real quick. So what you find is that elements that are in a family act alike. And as you go down, you go from slight reaction to 0 to 100 real quick. And this is the periodic table that most of you are used to. And this is the periodic table that most of you have seen. And it all started from the idea that what constitutes an atom and where it belongs are the protons. Now, we're going to pick up this conversation, but I want to let that marinate. Because basically, what I've said to you guys, you've listened to for like the last 2 weeks. But here's what I want you to understand. We're about to take this conversation from just a single atom to now a single cell. I want to thank you guys for watching. As always, I will see you next time. Have a good day.